Hello and welcome. In this video, we will very briefly demonstrate making a microrheology measurement using the NanoBrook series of dynamic light scattering instruments from Brookhaven Instruments. To understand a microrheology measurement, we first have to understand the Stokes-Einstein equation. In the Stokes-Einstein equation employed by dynamic light scattering, we are typically measuring the diffusion coefficient of the molecules or colloids in solution, inputting the solvent viscosity and the Boltzmann constant, measuring the temperature of the sample cell or the solvent, and then solving for DH or the hydrodynamic diameter. In microrheology, we are simply flipping the script and we are inputting the diameter of a known tracer particle that is non-interacting with your solvent, and then we are solving for the viscosity of the solvent. So again, instead of measuring the diffusion and solving for diameter, we are inputting the diameter, measuring the diffusion, and solving for solvent viscosity. In the software, here's the main interface. In the measurement type, make sure you choose a microrheology measurement, then click the New button to start a new measurement. When that measurement window pops up, we can then go in and set the experiment parameters. In this case, I will give the sample a name and I can give it other additional identifying information. Then we go to the instrument parameters. I'm going to use the 90-degree scattering angle for this experiment, and then I define the type of cuvette I'm using. Then we go on to measurement parameters. I'm setting my temperature, in this case, to 25 degrees. The duration of my experiment will be 60 seconds. I have taken out the equilibration time, but typically you would want to set this for a couple minutes to make sure your sample is equilibrated to the temperature or the set temperature of the sample chamber itself. We put in a known particle size range, and here is where we enter the known diameter of the tracer particles. Again, these have to be non-interacting with the solvent. There are some other parameters. One of the most important ones remaining is the known refractive index of the tracer particle. Once you have entered this, you can click OK and then click Start to begin the experiment. The instrument will go through an optimization step and then it will begin. And you see the upper screen here shows the raw autocorrelation curve. That is considered the raw data. And you will see your photon count rate in kilocounts per second. Here's your set temperature, the angle being used, your inputted known tracer particle size, and you will see the experiment counting down here as it progresses through. And on the bottom left, you will see it is collecting microrheology data. When the experiment finishes, you will see in the bottom left of that measurement window that the measurement is complete. We can close that window, go back to the main screen of the software, make sure we are looking at our microrheology results, click the refresh button to load that last measurement data, and here you see the measured viscosity of this solvent was 0.89 centipoise. It's as simple as that. Of course, there's much more to these measurements than I can get into in a quick video. We have a complete microrheology measurement quick start guide on our website. I will drop a link to that below in the description. Thank you so much for your time and attention here today, and please contact us for more information at brookhaveninstruments.com.